Hi, in this video, we're going to talk about introduction to probability, just some of the fundamentals. So let me just um, read a little definition of probability. I like to think of probability as the number of desired outcomes, number of desired outcomes over the total outcomes, the number of total outcomes. So I'm going to start out with a little problem here. I'm flipping 4 coins. 4 coins are flipped. And I want to find out out of these 4 coins, when we flip them, that I get exactly 2 tails. And I want to find the probability of getting exactly 2 tails. How many combinations are there that would give me these 2 tails? So when we have something like this one isn't too large. I can write out what I call a sample space. A sample space is listing all the different combinations. Sample space. So I'm going to list all the possible combinations that could come up. And that's what I'm going to write down in my, and I'm going to do this through what we sometimes call a tree diagram. Okay, so I'm going to start out here, and I'm going to flip some dice, and I can either get a head or a tail. This is the first. Then I'm going to flip it again, and I could get either a head or a tail here, or a head or a tail here. 2. So we see there's 1, 2. There's 2 combinations, 2 combinations. So I could get a head and a head, a head and a tail, tail and a head, tail and a tail. Those are my combinations. Now I'm going to flip it again. Each one of these. I'm going to get a head or a tail, head or a tail, head or a tail, head or a tail. 3rd time. So now I'm going to flip it one more time. Head, tail. I don't want to run out of room here. Head, tail. Getting smaller here. Head, tail. Let's circle these. Kind of so they don't. Okay. Head, tail. Not the prettiest, huh? Head, tail. Head, tail. Head, tail. Head, tail. So now I flipped them 4 times. Okay, so let's list this combination here. We got a head, 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 head. I'm going to write it down like this. Can you see that? Okay, here I got a head, 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 tail. I could put them underneath each other, but I know I'm going to run out of room, huh? So I've got this one, I got this one. I've got, now we're going to go to this one right here. I got a head, head, tail, head, 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 tail, head. And then I have a head, head, tail, tail. The reason I'm doing it this way is so we list all the combinations, which is sometimes hard to do. Head, head, tail, tail. Got that one, not this one yet. Let's circle that one. I've got a head. This group is done. Head, tail. Somehow I got a mess here. Here we go. Head, tail, head, 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 tail, head, head. Okay. Takes care of that one. Head, tail, head, tail. Head, tail, head, tail. All right, get rid of those. Okay, now I got a head, tail, tail, head, head, tail, tail, head. And then finally I got a head, tail, 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 head, tail, tail, tail. Okay, so this line of sight is pretty much gone. Okay, now I'm going to start with the tails. I got to, let's start them over here. I got a tail, head, 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 tail, head, head, head. I got a tail, head. I already did that one. Wait a minute. Tail, head, head, tail, tail, head, tail, head, tail, head, head, tail. Okay, that's this. I got a head, head, tail, head, head. I got a tail, head, tail, head, tail, head, tail, head. I got a tail, head, tail, tail. It kind of got really kind of scrunched together. Okay, so I've got that line done. Now I'm going to go this way. Tail, tail, head, head. Tail, tail, head, head. Tail, tail, head, tail. Tail, tail, head. Tail, tail, head, tail. Finally, I got tail, 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 head. Tail, 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 head. And finally, tail, 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 tail. Right. Okay. So this is what we would call a sample space. All the possible combinations that could come up. And we see that as 1, 2, 3, 4, 8, 12, 16. There's 16 combinations. That's my total. Now, what I want is how many of these come up with just exactly 2 tails? Here's one. This one has 2 tails. No, here's one that comes up with 2 tails. Here's another one that comes up with 2 tails. This one has 3. Here's one that comes up with 2 tails. Another one with 2 tails. No. And this one, 2 tails. Tail, tail, head, tail. Tail, 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 tail. So it looks like I come up with exactly 1, 2, 3, 4, 5, 6. 6 out of 16 have exactly 2 tails. I could have a head, head, tail, tail. I could have a head, tail, head, tail. I could have a head, tail, tail, head. That's the way they could come up. Tail, head, tail. Tail, head, tails, head. I'm going to make sure that that's not repeated. No. And tail, tail, head, head. So there's six different combinations that could come up. So sometimes, it's kind of hard to list all the sample spaces. Okay. But that's how exactly we could get it. Now let's look at dice. Let's look at a pair of dice. And let's suppose one is white and one is red. And if I roam, I can get different combinations, right? 2 and a 5, 3 and 3, 4 and 5, and so on. So this is the possibility of if I roll 2 dice, these are the different combinations that could come up. Let's suppose one is red and one is white. The first one's red and second one's white. I could have a 1 and a 1. I could have a 2 on the red, 1 on the white, or I could have a 1 on the red and then a 2 on the white. In other words, I could have this combination, red and white right here, 2 and 1, Or I could have it just the opposite. This could come up 2, and this would come up 1. It would be just the opposite. So that's a different combination. Now, notice when I have 2 3s, if I switch them, it's really the same thing, isn't it? It's still 2 3s. So we only count that once. So if I have a 3 and a 3, I don't write it down more than once. I just write it down once, 3 and 3. Okay. So we see here that there's 36 different combinations. There's 36 different combinations. I'm just going to fold this so I don't write it out. 36 different ways this could come up. So I'm going to try a problem here. I want to figure out, we're going to roll these 2 dice, and I want to see how many combinations will make a 7. A 7. How many combinations make a 7? And then I want the probability that it will come up a 7 as a fraction. You know, so we wrote these probabilities as a decimal here, but we could write this as a fraction. All I'd have to do is take my calculator. I can find one here. And I could divide 6, top number, by the 7, by the 16 combinations, and I could get 0.375. Or I could change that to a percent, 37.5 times that would come up, that particular combination. Usually you list them as a decimal. And we use 0 would mean it would never come up, and 1 would mean it always comes up. So we pick a number between 0 and 7. It'd be some kind of decimal number between those. If we're using percent, it'd be between 0% and 100%. We don't want to go over 100%. So 0 to 100%. Normally we list them as just a fraction. And if we have a fraction, we sometimes will reduce it by 2. Instead of 6 over 16, we could reduce that to 3 over 8. I would give you credit for either answer, but sometimes we can reduce them. So in this one, we want to see the combinations that make a 7. Okay, so I'm not going to show it all on the dice, but you could see I could have a 1 and a 6. Well, let's just do it this way. I could have a 1 and a 6. Can you see those okay? And I could have a 1 and a 6 isn't going to, 2 and a 6, see, that is not going to give me 7. Okay, so I need a 1 and a 6, a 2 and a 5, a 3 and a 4. Then I could switch them around. I could have a 4 and a 3, a 5 and a 2, and a 6 and a 1. Are there any other combinations? Let's see, could we go, let's see, we've already used all the numbers, 1, 2, 3, 4, 5, 6. So there's only 6 ways that the number 7 can come up. 6 ways out of how many? 6 ways out of 36. So there's only 6 combinations that will give you 7. A 1 and a 6, a 2 and a 5, a 3 and a 4, a 6 and a 1, a 5 and a 2. So sometimes we have to list those, because, and then we just list them, and then maybe I could reduce this to 1 over 6. Okay? And that's the number of combinations that we could have. How about the combinations less than, or the probability of a number less than 5, less than 5. What does less than 5 mean? Can I use the 5? No, it has to be smaller than 5. So I want the combinations that could give us, we can't roll a 1 with 2 dice. So what's the probability I roll either a 2, a 3, or a 4? We might say 3 out of 36. No. How many combinations make 2? To make a 2, there's only one way, one time, 1 and a 1. And we don't want to switch those, so that's it. To make a 3, what could you have? You could have a 1 and a 2, or a 2 and a 1. What about making a 4? What combinations make a 4? A 1 and a 3, or a 3 and a 1, and a 2 and a 2. So there's only one way to roll a 2. There's only 2 ways you can roll a 3. There's only 3 combinations that make a 4. So altogether, there's 1, 2, 3, 4, 5, 6. There's 6 numbers that could, 6 combinations that could come up that are less than 5. 6 combinations out of 36. So again, it just happened a coincidence. It would be 1 out of 6. So here we have to kind of list a sample space. We don't want to list the sample space for these because there's a lot of numbers here. So you can kind of see. To row a 4, you'd have to row a 1, it would be 1 and a 2. A 2 would be 2 and a 1, or a 1 and a 2 right here. And to row a 4 would be a 3 and a 1, a 2 and a 2, or a 1 and a 3. They're all this combination right here, 6 of them. They kind of form a little triangle right here. Okay. Now we're going to roll 2 dice. And one of the dice has to come up with a 4. How many different ways could that happen? So one of the dice has to always be a 4. The other dice could be any other number. Well, we can see there's 6 numbers here that could come up. We could have a 4 and a 1, a 4 and a 2. I'm just going to list them, a 4 and a 3, a 4 and a 4, a 4 and a 5, and a 4 and a 6. If the white dice was a 4. But what if the red dice was a 4? Let me get a 4. What if the red dice was a 4? This was the white dice and the red dice. What if the white dice, red dice now was a 4? 4 and a 1, 4 and a 2, 4 and a 3. I already put 4 and a 4, so I can't put that down again. 4 and a 5, 4 and a 6. Okay, so now the red is a 4 and the white is different numbers. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 ways out of 36. Okay, so that's how we could do it. 11 out of 36. Kind of fun, huh? So sometimes you do have to list sample spaces to get your combinations. Okay, let's try another one. Here's a deck of cards. And on the deck of cards, we're not going to use that card. We're not going to use jokers. We're not going to use these kind of weird cards. We're just going to use these cards here. How many cards do you think in this deck of cards are red? Half the deck. How many cards are in a deck? That would be, first of all, there's 52 cards in the deck, if I was to count all these. Half of them are red, 26 are red, and 26 are black. Okay. How many aces are there in a deck? Aces. Now let's take a look. Should be 4, huh? I don't know. I haven't looked at this deck. Here's 2. Here's another one. And here's another one. We see we have 2 red aces and 2 black aces. So there's a total of 4. 4 aces in the deck. Okay, picture cards. Or sometimes we call these face cards. Face is a more common way of saying it, face cards. Face cards, these are not face cards. A face card has to have a face on it. Whoops there. These are not face cards. Those are aces. So face cards are these cards right here. Let's see if I get it. Here's a jack. Here's another jack. See, they got a face on them. Here's a king, here's a king, here's another jack, here's a queen, here's a jack, here's a queen. Maybe I don't have a good deck. Here's a jack, queen, queen. I need another king. Here is a king. Okay, so you see we have 4 kings, 4 jacks, 4 queens. Count them up, 4, 8, 12. There's 12 picture cards in the deck. 12 picture cards. So there's 12 face cards in the deck. So how many number cards do we have? Well, all the cards that are left are considered number cards. These are considered number cards. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36 is what I count. And if I add all these together, I should get 52 cards. So there's 36 number cards in the deck. Okay. So let's suppose I pick a card out of this deck of cards. I just randomly pick one card. I just turn it over and pick a card. Boom. What's the chance that that would have come up a 2? A 2 of diamond. Well, there's only one of those in the deck of cards. So there's 1 out of 52. That's the probability. One chance out of 52 I would have drawn that card. Okay, but let's say I keep that card and I don't put it back in the deck. What's the chance if I draw again? I drew one card out of the deck and I don't replace it. And that's the way it goes. What's the chance of that it would be? I just drew one card out of the deck. 1 out of 52. Okay, let's just leave it like that. Okay, what's the chance? Now, let's talk about suits. There's hearts, diamonds, spades, and clubs. Okay, each one of these has 13 cards in them. They have an ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, so each one, and this would be 4 times 13 is 52. So what's the chance I draw a spade out of this deck of cards? Well, I have 13 chances out of 52. If I reduce that, I have a 1 out of 4 chance that it would come up a spade. Let's see what happens. Just randomly draw a card, and it was a heart. Okay, well, anyhow, what's the chance of drawing a queen? 1 out of 52? No, there's 4 queens, remember? There's 4 queens in the deck, so 4 out of 52. The chance of drawing a queen. So that's how we figure out the probability on this thing. So what's the probability that I'm going to draw a red card? Okay, let's look at our suits. Hearts and diamonds are both red. So half the cards right here are red. The chance of drawing a red card is 26 out of 52, or half the deck. Okay. What's the chance of drawing an ace? There's 4 aces in the deck, 4 out of 52. What's the chance of drawing an ace of hearts? An ace of hearts, there's only 1 out of 52. So that's what you want to kind of do. That's how probability works. The possibility of what you want to get out of how many total there are. I want to draw an ace. There's 4 aces, but there's 52 cards. So you get yourself a deck of cards and you can kind of fool around with this probability stuff. Let's try one more here. I have a drawer, a dresser drawer, and in that drawer I keep my socks. And in the socks I have pairs of socks. And I have 5 pairs of black socks. I have 4 pairs of blue socks. I have 3 pairs of white socks. And I have 2 pairs of red socks. I randomly go into the drawer and I have my eyes closed. It's dark, the room's dark. I grab a pair of socks. What's the probability it will be blue? Okay. Well, there's 4 pairs of blue socks. So the probability it would be 4. I have 4 chances that it'd be blue. But out of how many? So we have to add all these together. 5 and 4 is 9. 9 and 3 is 12. 12 and 2 is 14. There's 14 pairs of socks in the drawer. I have a probability of picking a blue one is 4 out of 14 or 2 out of 7, huh? And that's the probability I would draw a pair of blue socks. What about white socks? 3 out of, there's still 14 pairs in here. 3 out of 14. Okay. So that's how probability works. It's just that way. Now, in the book, they have another one here. It says, we select from a standard deck of cards, 52 cards, and without returning to the deck, we select a second card. We assume the order is not important. What's the probability of that happening? We're going to select one card out of this deck of cards, and then how many different ways there are. So if we select a card, there were 52 cards we got to pick from. But the next time, suppose I wanted to pick 2 hearts in a row. I want to pick 2 queens. The probability of getting a queen on the first one is 4 out of 52, right? I got 4 chances, but I don't put that queen, and let's suppose I got a queen. I don't put it back into the deck. I keep it. What's the probability I draw a queen again? Well, there's only 3 left in the deck because I'm holding one in my hand. I'm holding a queen in my hand. Where's a queen when you need one? Here it is. I picked this card. I just pulled it out of the deck. Queen. Now I'm holding it. What's the probability I draw another queen out of the deck? 3. There's only 3 queens left, but there's only 51 cards left because I'm holding one in my hand. So the probability of drawing 2 queens in a row is 12. 4 times 3 out of 52. I'm going to have to use my calculator. 52 times 51. 2,652. Not a very good chance that I'm going to draw 2 queens in a row, huh? There's only 12 cards out of 2,652 chances. Okay, so this is how probability works. We'll talk about this one later on in the course, but right now we're just going to work with simple probability. So sometimes you have to list the combinations. You know, I don't list all the total combinations, but list the combinations that would give you a 4, combinations that would make 4. See, just a row of 4, there's only 3 ways you can do it. Number is less than 4, there's 6 different ways that could come up. And you could do the same thing for numbers bigger than 8 and so on. So practice these a little bit, and I hope this helps. I'm going to try to get out of here today.